Take a look at this example. A simple random sample of size n is drawn from a population that's normally distributed. The sample mean x bar is found to be 50, and the sample standard deviation s is found to be 8. So we're told that x bar equals 50, and we're told that s equals 8. Now, this is kind of a concept question. You're kind of exploring what happens as we change things. So in question A, we want to construct a 98% confidence interval for mu if the sample size is 20. So in A, our sample size is 20, which means we have 19 degrees of freedom, and we want to construct a 98% confidence interval. So I'm going to use my calculator to do that. So I'm going to go to stat, test, and t-stats, or t-interval, I should say. In this case, I have statistics, not data. X bar is 50, S is 8, my sample size is 20, and we're doing a 98% confidence level. So if I calculate, that confidence interval is 45.457 to 54.543. So I'm 98% confident that the true mean is somewhere between 45.457 and 54.543. The calculator doesn't tell me the margin of error directly, but I can find that if I take 54.543 and subtract the 50, the point estimate, that is 4.543. So my margin of error was 4.543. B, construct a 98% confidence interval for mu if the sample size is 15. How does decreasing the sample size affect the margin of error? So in other words, if the 50 and the 8 are the same, but if my sample size drops from 15, which means I now have 14 degrees of freedom, and if I'm still doing a 98% level of confidence, how does dropping from 20 to 15 affect the margin of error? Well, if I go to stat and test and t-interval, I've got statistics, x bar is 50, s is 8, n is 15 in this case. I still have a confidence level of 98%. So if I calculate, my confidence interval changes to be 44.579 to 55.421. So dropping the sample size from 20 down to 15 widens my confidence interval. If I take 55.421 minus 50, that is my margin of error, so that is 5.421. So what's the point? As the sample size decreased from 20 down to 15, with everything else staying the same, the margin of error increased, which made the interval wider. Or you could look at that from the other perspective. If I increase the sample size from 15 to 20, the effect is that the margin of error would decrease and my confidence interval would narrow. So we can increase the accuracy, so to speak, of our confidence interval by increasing the sample size. Now, to directly answer the question here, how does decreasing the sample size affect the margin of error? Decreasing the sample size increases the margin of error. So that's the point of the question. What's the effect of, in this case, decreasing the sample size? So again, we can increase the accuracy of our confidence interval by increasing the sample size. The only trouble with that is there's a trade-off. If you increase the sample size for your study, you are also increasing the expense of your study. So you have to find a balance. What's accurate enough for my budget? Look at C. Construct a 95% confidence interval for mu. If the sample size is 20, compare the result to those obtained in part A. How does decreasing the level of confidence affect the margin of error? So again, we still have x bar equals 50. We still have s equals 8. But now we're back to n equaling 20, which means we're back to 19 degrees of freedom, but we're dropping to 95% confidence. And our question is, how is that going to affect the margin of error? Well, doing another t interval. So I have stats, so 50 and 8. Now my sample size is back to 20, but my confidence level is dropping to 95. So when I do that, my confidence interval is 46.256 to 53.744. So my margin of error is going to be 53.744 minus 50, so that is 3.744. Now we're supposed to compare that to our answer in part A. In part A, everything was the same as C, except in A, we had 98% confidence. In C, we had 95% confidence. So when I dropped from 98 to 95% confidence, the margin of error dropped down to 3.744. So decreasing the level of confidence decreases the margin of error. And just to be clear on that, if it decreases the margin of error, then that gives us a narrower confidence interval. Whereas in B, if I decrease the sample size, that gives us a wider confidence interval. D, could we have computed the confidence intervals in parts A through C if the population had not been normally distributed, and why? Well, they told us up here that N is drawn from a population that's normally distributed. In these cases, our sample sizes were 20 and 15. So we would not be able to do these because that's not big enough. So the answer would be no. Sample sizes of 20 and 15 would require the population to be normal. Otherwise, we would have to have sample size of 30 or bigger for the central limit theorem to kick in to be able to use the t-distribution.